Okay everyone, let's go through 1.5 forces together. If you look at this question here, what do they want from you? A piece of metal is taken from Earth to the moon for an experiment. The gravitational field strength on the moon is smaller than the Earth. The gravitational field strength of the moon is smaller than the gravitational field strength of the Earth. Which statement about the piece of steel is correct? It has less mass on the moon than on Earth. Not true. Mass does not ever change. It has more mass on the moon. Not true as well. It weighs less on the moon than on Earth. Definitely true, because weight is affected by gravity. A boat is traveling at a steady speed in a straight line across the surface of the lake. Which statement must be true? Now, whenever you see the word steady speed, a steady speed can only occur when there are zero resultant forces and thus zero acceleration. The resultant force on the boat is in the direction of the motion. Not true. The resultant force on the boat is opposite of motion. Not true. The resultant forces on the boat is vertically downward. Not true. The resultant force on the boat is zero. Definitely true. In order for anything to move at a constant speed, it must have zero acceleration and thus zero resultant force. Question number 3 here. A ball of weight 1.2 newtons drops through the air at terminal velocity. Yet again, another keyword here. A sudden gush of wind exerts a horizontal force of 0.5 newtons from the left. Which diagram shows the resultant force of the ball while the wind is blowing? Now, a lot of students are very tempted to circle this as the answer, because they think that this is the wind and this is the weight and this will be the resultant force, right? But the key word here is actually terminal velocity. For anything to move at terminal velocity, you have to understand that the upward forces must be equals to the downward forces, and thus C is the only logical answer, because the upward force is equals to the downward force. This gives terminal velocity, and this horizontal forces will have zero effect on the vertical forces here. Very important key thing to note here. Alright, then after that, question number 4, the diagram shows a uniform bridge 4 meters long and weighs 10,000 newtons. The bridge is pivoted at one end. A force at the other end gradually increases until the bridge begins to lift. What is the lifting force as the bridge starts moving upwards? So basically, first and foremost, we identify that this is the weight of the bridge, which is obviously going to act at the middle here. There is actually 10,000 newtons of force acting here. And since I see the word pivot, I know for a fact that this has to do with momentum. And since there are two forces, one that is acting anti-clockwise and one that is acting clockwise, I know that this is basically the moments in equilibrium formula, which states that the total anti-clockwise moment must be equals to the total clockwise moment. From here, I just need to find how much moment this will generate, which is the clockwise, how much moment this will generate, which is the anti-clockwise, and I should be able to find the answer. From here, since force times distance is moments, right? The F here, this is your F, multiplied by your distance, which is going to be 4. It's equals to your F here, which is your 10,000 newtons, multiplied by the distance to the pivot, which is going to be this 2 meters here, right? From here, press everything into the calculator, you'll get that F is equals to 20,000 divided by 4, which is essentially going to be 5,000 newtons. You need 5,000 newtons here to lift this bridge upwards here. Then after that, in which pair are both quantities measured in newtons? Obviously, force and weight is measured in newtons. A spring which obeys Hooke's law has an unstretched length of 10 cm. This is the original length. A load of 20 newtons is hung from the spring. The new length of the spring is 36 cm here. Right, so from here, what is the spring constant? If I want to find the spring constant, you have to get back to Hooke's law's formula, which is F is equals to Kx, right? If F is equals to Kx here, then in order to find K, I need to have the F and also the X are just simple algebra. From here, the force is obviously going to be 20 newtons, and the extension originally was 10 cm extended to 36 cm, right? The extension here would obviously be 26 cm. From here, if you press everything into the calculator, 20 divided by 26, you'll get a total of 0.77 lah. 0.77 newtons per cm. Make sure your units are all correct, guys. Then you should be able to get the proper answer here. Alright, moving on. A car travels along a straight road. Only the horizontal forces acting on it are shown. The length of each arrow represents the size of each force. How do these forces affect the motion? From here you can see that this backward force is greater than this forward force here. In other words, there is a resultant force backwards, right? If there is a resultant force backwards, the car could possibly be moving backwards. But since this car is already moving forward here, it is basically decelerating lah. And in other words, he is slowing down. So answer is C here. Alright. Then next question. The diagram shows a wooden beam weighing 20 newtons. The center of mass of the beam is labeled F. This is the center of mass. There is a pivot at one end of the beam. The beam is kept horizontal by a upward force F here. So this is the pivoting point. This is 20. This is F. What is the magnitude of your F here? Yet again, this is basically moments in equilibrium, which states that the total anti-clockwise moment must be equal to the total clockwise moment. From here, I know for a fact that the anti-clockwise moment will be generated by this thing here, which is going to be F multiplied by 2, is equals to this thing here, which is the clockwise moment, which is going to be 20 multiplied by 1.2. Press all of that into the calculator. You'll get 10 times 1.2, which is essentially going to be 12 newtons here, yeah, guys. The diagram shows an object being acted upon by two forces, 1.6 Newton and 1.3 Newton. What is the size of the resultant force of the object? This is a dumb, straightforward question. Obviously, the resultant force is 3 newtons towards the right lah. Okay. And finally, question number 10. Oh no, not finally. Many more to come. Question number 10. The diagram shows a man holding a sack and barrel stationary. He applies a vertical force on the handle. This is the force applied. The center of mass and the weight of the sack barrel are shown. The wheel acts as a pivot. If they say that the wheel acts as the pivot, this will be the pivoting point, right? What is the magnitude of the vertical force exerted by the man? Now, I do want to highlight these kind of questions in your IGCSEs. You see that they give you a lot of random information, right? From here, the first things first is you have to understand that this is definitely moments in equilibrium, right? Which states that yet again, the anti-clockwise moment must be equals to the total clockwise moment. From here, it's obviously going to be F1D1 equals to F2D2 lah. F1D1 is equals to F2D2 here. But from here, if let's say I understand that this is the pivoting point and this is the first force, let's say this is 200 newtons, multiplied by the distance. Some students, they are very inclined to use this 20 cm instead of this 15 cm, but you guys have to remember that the forces are always perpendicular to the distance. So whatever random information the question gives you, you must ignore it and only focus on the perpendicular distance, which in this case here is obviously going to be 15 now. Is equals to the force, which is the force exerted by the man, right? This is the other force here, right? F, I don't know how much is it, but the distance here, a lot of students may circle 80 as the answer, or 45 as the answer, or sometimes even 20 as the answer. This is absolutely not true as well. Yet again, you have to understand that it is perpendicular distance to the force from the pivot, right? Which in this case here is supposed to be 60. Yeah? So from here, press everything in the calculator. 200 times 15 divide by 60, you will get a final answer of 50 newtons. Alright, just be very careful. It is always force perpendicular to the distance. Then the diagram shows only two forces, F1 and F2, acting on an object. The magnitude of each force is represented by the length of each arrow. The resultant force acting on the object is R. Now, there are basically two forces acting here, and you have to understand that when there are two forces acting on an object, the resultant force will always be in between the two forces here, yeah, guys. So from here, what do you have is you understand that the resultant force is somewhere here. You start looking at each and every one of these diagrams and see which one makes sense. A is definitely out of the question. Why? Because if you see here, this R has a greater gradient than F1 here. So in other words, right, they're basically saying these two forces, F1 and F2, is going to result in a resultant force in this direction, which is absolutely not true lah, right? Looking at B, this one is even more ridiculous. They're saying that the resultant force is in this direction, which is quite dumb, right? C is not true as well. C is basically saying that the resultant force is in that direction. Finally, we have D as the answer. Why is D the answer here? Because the resultant force, the force 2 and the F1 are all in the proper direction here. You can see that this F1 is in the proper direction, F2 is in the proper direction, and R is actually in the proper direction as well. It is in between the two forces. So naturally, donkey should be the answer for this question here. And finally, yes, this time finally, the diagram shows 4 bodies moving in the direction shown. The only force acting on the bodies are shown in the diagram. Which body gains the most kinetic energy when moving a distance of 1 meter here? Right, so basically, in order to have the greatest kinetic energy, it must have the greatest resultant force, right? Looking at this diagram here, obviously this is the one now, because the resultant force here is 10, here would be 10, here would be 0, and here would be 15, right? So naturally, C is going to be the answer for this question here. Then, moving on to the next part. Figure 3.1 shows a remote sensing equipment on the surface of a distant planet. The mass of the equipment is 350 kg. The acceleration of free fall is blah 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 blah. What is meant by the term weight? Now, in your IGCSEs, if they ever ask you to define anything with the formula, first and foremost, yet again, you have to understand that weight is equals to mg, right? If they are multiplying each other, it should be the product of each other. So from here, I can say that weight is the product of mass and gravity, right? It is the product of mass and gravity, which is defining this formula here. Then next part is they ask you to calculate the weight of the planet. W is equals to mg. 350 is multiplying by 7.5. Press that into the calculator. You will get 2625 newtons. And when you're writing any answer in this dotted line here, bear in mind that it can only be correct to 3 significant figures. So your final answer here should be 2630 newtons. Alright. Then the equipment releases a balloon from a point that is small distance above the surface. The atmosphere at the surface of the planet has a density of 0.35 kg per meter cube. The inflated balloon has 80 grams and has a volume of 0.3 meter cube. Make an appropriate calculation and then predict and explain the direction of any motion of the balloon as show your working. Right, basically if you look at this question here, they're basically trying to test you on the fact that will this balloon float upwards or will it sink downwards. And if you think about floating upwards, the only reason it could float upwards is because it has less density than the density of the air on that planet here. So first and foremost, I have to find the density of the balloon now, which I noticed that this here is actually in grams, this here is actually in kg. First things first, I change this into kg lah, which is divided by 1000, which is going to give me 0.08 kg here. From here, density is equals to mass over volume, which in this case will be 0.08 divided by 0.3. Press that into the calculator yet again. It will get 0.267. You will get 0.267 kgs per meter cube. Now comparing this density with this density here, you can see that the balloon obviously has less density than the air around it, right? So my prediction is obviously going to be the balloon floats, the balloon floats upwards. Explanation: the density of the balloon is less than the density of the air in the atmosphere of the planet. Okay, these are going to be your answers here. Then finally we have a vector question. The boat B, this you don't care where B is moving due west at a speed of 6.5 meters here. West is obviously towards the left. The water is moving due south. South is obviously downward here. In the space below, draw a scale diagram to determine the size and also the direction of the resultant force of these two velocities. State the scale used. Now, first and foremost, when we deal with these kind of questions here, I always like to do a mini-map diagram, right? If they say that there's one force acting on the left and one force acting towards the right, I'll have something like this, right? I'll have one force here and another force here. And I know for a fact that my resultant force should be in this specific direction, which then leads me to forming the triangle method, which would end up something like this, right? The triangle is going to have it's going to look something like this, right? From here, once I have this diagram, I'm going to draw my scale, which in this case here will most likely be 1 cm equals to 1 meters per second. From here, I know for a fact that this should be 6.5 cm, this should be, this should be 6.5 cm, and this should be 3.5 cm here. From here, you know, once I have these two things, just draw it properly with your ruler. You should get a diagram that looks something like this, right? This is you label everything now, right? This is 3.5 cm, this is 6.5 cm. Then after that, measure however long this distance is, and this will be your answer of your resultant force. Now, once you're done with all these diagrams, right, your scale should be 1 cm representing 1 meters per second. The size of the velocity is dependent on however much you have here, right? You can also cheat on these kind of questions using the Pythagoras theorem, which is going to be 6.5 square plus 3.5 square root that answer. You are supposed to get a final length of 7.4 cm here, which is going to translate to 7.4 meters per second. And the direction of the resultant force could in order to find the direction of the resultant force, you have to measure what this angle is. Let's say, for example, here is 25 degrees, right? You can mention that it is 25 degrees in the southwest direction, the southwest direction here. 25 degrees towards the southwest direction. Okay, do your own drawing here, guys. Then moving on to the next set of exercise. A student wishes to determine the spring constant of a spring where it obeys Hooke's law. Very important keyword here. Different loads are hung from the spring and the length is measured from each different load. The table shows the result of the experiment. 0 newtons, it is length at 12 cm, so this is the original length. 2 newtons, that is length at 20 cm, which means to say the extension would be 8. Here, 4 newtons, the extension would have been 16. And here, 5 newtons, the extension would have been 26 here. What is the value of the spring constant here? Very straightforward. Yet again, Hooke's law's formula is F equals to Kx. K would have been equals to F over X. In this case here, I'll probably use this as an example. 2 newtons divided by the extension of 8 should give me a final answer of 0.25 newtons per cm. Okay? You can use either one of it, you should get the same answer as well, like this one here. Probably not this one though, this one would probably exceeded the Hooke's law already, the elastic limit. But anyhow, if you use either one of these two, you have gotten the same answer as well. The mass of 20 kg is held stationary by a rope passing over a frictionless pulley. What is the tension of the rope here? Now, tension is basically measured in newtons as well. And if this thing here is 200 newtons downwards, this tension must be the same of 200 newtons upwards in order to balance off this whole arrangement, right? So answer is donkey here. Then a boat starts moving across the river with velocity v. Perpendicular to the riverbank, the boat encounters a current along the river with u. This here as shown, which vector diagram shows the resultant force of R, which is obviously supposed to be in this specific direction, right? So looking at these diagrams here, this is obviously the only logical one because U will still be U, V will still be V, and your resultant force is obviously towards the bottom right here, right? For those who have a hard time imagining this, you can imagine that there's V here and then there's U here, and the resultant force is obviously here, guys. Just rearrange it into a proper triangle, and you should get the answer as C as well. And question 4, an experiment is done to determine the spring constant for a spring. Different loads are hung from the spring and its length is measured for each different loads. The graph shows how its length varies with load. Blah, 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 blah. What is the value of the spring constant here? Now, yet again, if you want to find spring constant, obviously it's F is equals to Kx, right? Then spring constant K will have been equals to F over X. From here, all I need to do is find the load, which is probably somewhere around here. I can use either one. I can use this or this or this. I think all of it will be the same. If I use this 2 newtons here, I need to find the extension. This is the length of the spring, guys. Don't straight away go like 2 divided by 12 and then you get some funny answer here. That is definitely not the case. You need to find the extension. The original length is 4 cm and the extended length is actually going to be 8. So from here, yet again, it's going to be 2 divided by 8, which is going to be 0.25 newtons per cm, yet again. You can find other values here as well. You will get the same answer, guys. Alright, then the beam is pivoted at its center of mass. It is acted upon by 2 forces, 10 newtons and 5 newtons here as shown. What is the resultant moment of the pivot? So first and foremost, I need to find how much moment is generated here and how much moment is generated here. Looking at this information, the anti-clockwise moment will be 5 multiplied by 15, which is 75 newtons cm. And this here would have been 10 multiplied by 10, right? Because it's distance to the pivot. It will be 10 newtons multiplied by 10 cm, which is going to be 100 newtons cm here. So from here, I can clearly see that the clockwise moment is greater than the anti-clockwise moment, right? So the resultant moment will be 25 newton cm clockwise direction. Which object is in equilibrium? No need to say so much. Obviously C, nothing to explain here. An experiment is carried out to determine the spring constant of a spring that obeys Hooke's law. A load is hung from the spring and the extension of the spring is measured. Which calculation is used to calculate the spring constant? F is equals to Kx, or K will have been equals to F over X. So weight of the load over extension is the only logical answer here. A car is driven from rest initial velocity on a long straight road. The car engine exerts a constant driving force. The diagram shows the horizontal forces acting on the car. The resistive forces are proportional to the speed of the car. This statement here is basically saying that air resistance increases with your speed. Why does the car eventually reach a maximum speed? The resistive force decreases to make the acceleration? No. The resistive force decreases? No. The resistive force increases to make the acceleration of the car negative? No. The resistive force increases to make the acceleration of the car 0? Definitely true, because as the car speeds up, the air resistance increases. This results in 0 resultant forces due to the fact that the forward force is equals to your backward force here, right? Then moving on, a beam of weight 6 newtons suspended from 2 springs P and Q. Oh, there's 2 springs here. There's P. Oh, string Q is not shown. Okay. The tension on spring P is 2 newtons here. What is the tension in the string Q and where is it attached so that the beam is in equilibrium? Wow, what an interesting question. So from here, what do we have? There's 2 newtons here, there's 6 newtons here, and there is probably some spring Q here, right? First and foremost, I know that the upward forces must be equals to the downward forces. If there is a Q here, the upward forces here should be equals to the downward forces, so C and donkey should definitely be out of the question. So it's a matter of trial and error between the 10 cm and 15 cm from the left, right? Let's assume that this is going to be 10 cm from the left side here, and this is going to be the 4 newtons. From here, will this make sense? How do we check this out? We have to make the pivot at one of these points here. So if I simplify the whole diagram, pivoting point, one force here and another force here, the diagram will look something like this, right? Pivoting point at Q, one force which is the 6 Newton and another force which is the 2 Newtons here. The 6 Newtons will be 10 cm away from the pivot because it's 20 minus 10, right? And the 2 Newtons will be 20 cm. It will be 20 cm away from the pivot because it's 30 minus 10, right? Will this be in equilibrium? Force times distance 40, force times distance 60. No, this will not be in equilibrium. Instead, it should be in the 15 cm mark, and let's check this out. If this was at the 15 cm mark, redrawing the diagram will be 6 newtons here and yet again 2 newtons here. The distance from Q, this is basically Q, to here would be 5 cm. And here to here would have been a total of 15 cm here, right? So 5 times 6 would have been 30, 2 times 15 would have been 30. Answer would definitely be B in this kind of question. Guys, when you're dealing with all these strings, you're dealing with all these string questions, right? You have to make one of the strings the pivot so that you eliminate one of the forces away, then you can do moments in equilibrium and find which one is actually in equilibrium. In this case here, B is definitely going to be the answer, because if Q was 15 cm away, right, making this the pivoting point, here would be 5 multiplied by 6 would be a clockwise moment of 30 Newton cm, and here would be 15 multiplied by 2 would have been an anti-clockwise moment of 30 Newton cm as well. So answer can be no other than B. Okay. Moving on. Next question. Figure 2.1 shows a sign that extends over a road. The mass of the sign is blah 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 blah. This mass should be 3.4 times 10 to the power of 3. What is the weight of the sign? Weight is equals to mass times gravity, and since this is an older paper, it will be 3.4 times 10 to the power of 3 multiplied by 10. The new silver's gravity is 9.8 by the way, so be careful when you're doing it in your real exam. So 3.4, nothing to calculate here, 3.4 times 10 to the power of 4 newtons, right? 3.4 times 10 to the power of 4 newtons here. God forbids a use of a calculator here. The weight of the sign acts at a horizontal distance of 1.8 meters from the center of the support post and produces a turning effect about point P. Now, keyword here about point P means to say that this is eventually going to become the pivot. P is a horizontal distance of 1.3 meters away from the center of the post. So if this is the pivoting point, and they say that this here is 1.8 meters, this here is 1.3 meters, the next thing is they'll ask you to calculate the moment about point P due to the weight of the sign. In this case here, since this is the pivoting point and this is the force, the distance to the pivot perpendicular to the force is only 0.5, right? Pressing that into the calculator will be basically 3.4 times 10 to the power of 4 divided by 2 right? 3.4 times 10 to the power of 4 multiplied by 0.5, which is divided by 2. Press that into the calculator or not, you'll get 1.7 times 10 to the power of 4 Newton meter. Okay, you'll get 1.7 times 10 to the power of 4 Newton meters here. A concrete block is positioned on the other side of the support post with its center of mass a horizontal distance of 70 cm from the support post. So this thing here is 70 cm away from the support post. State what is meant by center of mass. Center of mass by definition is the point where all mass is acted upon or concentrated upon, right? Basically it's saying that all mass acts at this specific point, which is known as the center of mass. Then after that, the weight of the concrete block produces a moment about point P that exactly cancels the moment by weight W. Calculate the weight of the block. So they're basically saying that the moment generated by this concrete block about point P, obviously an anti-clockwise moment, will be equals to the clockwise moment generated by the weight here, right? So from here, what you have to do is basically moments in equilibrium all over again, right? Moments in equilibrium states that the total anti-clockwise moment must be equals to the total clockwise moment. From here, how much force is this? Force on this, I don't know. Right, let me simplify the whole diagram, by the way. It will be like 2 meters here because it's 70 and 1.5, right? This is 70 cm, by the way. So there's one force here. I don't know how much that is, but it will be balanced off by this thing here, which is 0.5 meters away and has a weight of 3.4 times 10 to the power 4 newtons, right? So from here, it's essentially just writing everything down, right? It's going to be F multiplied by 2 is equals to 3.4 times 10 to the power of 4 multiplied by 0.5. In this case here, press everything into the calculator. 3.4 times 10 to the power of 4 times 0.5 divide by 2, you'll get a total weight of 8,500 newtons here. 8,500 newtons. And finally, the concrete block is removed. Actually, pause this recording first. Okay, moving on to the next question here. The concrete block is removed. The sign and support post rotate about point P in a clockwise direction. State and explain what happens to the moments about point P due to the weight of the sign as it rotates. Basically, this question here is saying that, oh god, let me rub everything away. Okay, they're basically saying that this question here is saying that this thing is removed, and because this thing is removed right now, there is obviously a clockwise moment by this weight of the sign here. And if this thing rotates but in a clockwise moment, they're asking what would happen to this moment as this thing continuously tilt in the clockwise direction. Now, if you look at this, if you can imagine this scenario here, right, the next instance that this thing rotates will be probably in this, position here, and the next instance that this thing rotates will probably in this instance here, right? You can see that while this is supposed to be the pivoting point, right, as it starts rotating clockwise, the distance from the pivot starts to increase. You know, this will be the pivoting point and this will be the weight. You can see that the distance from the weight of the sign starts increasing. This indicates that the moment generated as this thing continues rotating in the clockwise direction is actually going to increase. So from here, you're supposed to state that moment of the weight about point P increases because the distance from the pivoting point increases. As the thing starts rotating in a clockwise direction, you can see that the distance of the weight from the pivot increases, and thus it's supposed to increase in terms of its moments here. Okay, last question here. Figure 2.1 shows a model fire engine. Its brakes are applied. 0.8 kg of water is emitted in the jet every 6 seconds at a velocity of this. Mass, there's time, there's also velocity relative to the model. Calculate the magnitude of the force acting on the model because of the water jet. Now F is obviously supposed to be MA here. Since I do not have A, I need to find A, right? A would have been equals to V minus U over T. From here, A would have been 0.72 minus 0, because initially it was at rest, right? Divide by a total of 6 seconds. Press that into my calculator, 0.72 divided by 6 seconds here. I'll get an acceleration force of 0.12 meters per second. Once I have this, I can substitute this acceleration into here. F is equals to MA, right? So F will be equals to 0.8 multiplied by 0.12. This thing here multiplied by 0.8. I'll get a total force of 0.096 newtons here. 0.096 newtons. The bricks of the models are released. State and explain the direction of the acceleration of the model. Obviously, if the water is rushing in this direction, once I release the brakes, this thing here is going to move towards the right side lah, right? So your statement is that the model moves towards the right. An explanation is because the resultant force due to the water jet pushes it towards the right. Okay. Then next part here, finally, in C, the model contains a water tank which is initially full. This is a keyword here. State and explain any changes in the magnitude of the initial acceleration if the brakes are first released when the tank is nearly empty. Now this question here is basically trying to test your understanding, you know. This model jet here will definitely apply a constant force of water stream here. Let's just say the force here is 100 newtons. But in this question here, they say that the water tank was initially full, meaning to say the mass was high. And then after that, when it is nearly empty, the mass is low. Looking at the F equals to MA formula, right, they're asking us what happens to the acceleration, right? The acceleration would be F over M lah. Today, as the mass starts decreasing due to the water tank getting empty, right, what's going to happen is the acceleration of the model will increase as well. This is the reason why your car, right, your parents' car, when they are driving at a near empty tank, it always feels that it goes faster because it is much easier to accelerate given that the engine force is going to be constant. So my statement here is obviously let me erase all this away. My statement here is acceleration increases. Why? Explanation: as the mass decreases, a constant force from the water jet increases the acceleration because acceleration is inversely proportional to the mass. Okay, and this is how you're supposed to answer these kind of questions here. Okay, looking at the final exercise here, question number 1. A car is traveling around a circular track at a constant speed as shown. In which direction is the resultant force on the car? Now you guys have to understand that whenever any object is moving in a circular motion, right, there will always be a resultant force and also acceleration towards the center of the circle. This is always asked in your IGCSE questions, so make sure to circle anything that is pointing towards the center of the circle. Question number 2. Two forces P and Q act on the meter ruler as shown. The meter ruler is pivoted at one end. The rule starts to rotate in a clockwise direction. It is rotating in the clockwise direction, indicating that the moment generated by P in the clockwise direction is greater than the moment generated by Q. So which statement is correct? They say that P is equals to Q. This is definitely not true because Q would have a greater distance, thus creating a greater moment. P is less than Q. This is not true as well, because if P was less than Q, Q's distance is already greater. If Q is greater, it will generate an even greater anti-clockwise moment. P times A is equals to Q times B. Q times B represents nothing, yeah. The distance is always with reference to the pivot. So P times A is greater than Q times A plus B. This is definitely true because the clockwise moment here will be greater than the anti-clockwise moment here. Which statement gives a correct description of any object that is in equilibrium? There is no force acting on it. Not true. The forces should be in equilibrium. No resultant forces. This could be possible. There is no resultant forces and no resultant turning effect. This is definitely true. Now in your IGCSEs, they always like to ask you what are the two conditions for any objects to be in equilibrium. The answers are always no resultant forces and no resultant moments. Keep that in mind. Next part. A hook is used to lift a metal plate as shown. An upward force of 100 newtons is needed to lift the metal plate above the pivot. This is the pivoting point here. As shown, what is the weight of the metal plate? I'm finding basically the clockwise moment would have been equals to the anti-clockwise moment here. From here, yet again, total clockwise moment is equals to total anti-clockwise moment. From here, the clockwise moment will be W times 50 is equals to 100 multiplied by 90 because it is always distance to the pivot. From here, press everything in the calculator. You should get 180 newtons here, yeah, guys. What's the units of moments of force? Is obviously going to be Newton meter because moment is force times distance, right? Then question number 6, a ship travels due north in the upwards direction through still water at a speed of 20 meters per second. It enters a channel where there is a current from the west to east. West to east is towards the right direction. The speed of the current is 20 meters per second. Which diagram shows the resultant forces? Yet again, there's one upward force, one rightward force. It should have a resultant force towards the right. So naturally, C is going to be the answer here. Okay, moving onwards with question number 7. The diagram shows a uniform meter ruler. The rule is pivoted at the midpoint. So this is the pivoting point here. The downward force is 4 newtons here. The ruler is on the ruler at 5 cm mark this here. The rule is held by a string at the 30 cm mark here. The rule is in equilibrium. Yet again, if it is in equilibrium, it means to say the anti-clockwise moments must be equals to the clockwise moments with reference to the pivot, right? So from here, how much will the anti-clockwise moment be? It's basically going to be 4 multiplied by 45. And here is equals to your force. I don't know how much is this. F multiplied by your 20 here. Press this into your calculator. You'll get 1/5, you'll get exactly 9 newtons here, guys. You're supposed to get 9 newtons here by using algebra. Question number 8. A ship sails north. Hey, this is the same question again, right? North 20 meters per second, and from east to west, this time is in that direction. What's the magnitude of the resultant force? This one here, it will be best if you use the Pythagoras theorem, which is 20 square plus 20 square square root. You'll get exactly 28 meters per second. Right? And moving on to paper 4. State 2 properties of an object that may change by the action of the force. There are a lot. It could change the direction. It could accelerate it. It could decelerate it. It could also change the shape of it. Right, so these are all the actions that is going to be applicable due to a force. A chest expander is a piece of equipment used by athletes in a gym. Figure 2.1 shows a chest expander that consists of 5 identical springs connected in parallel with 2 handles. Each spring has an unstretched length of 0.63. This is the original length. 2 athletes are stretching the chest expander by pulling on 2 handles in opposite direction. The spring obeys Hooke's law. What does this statement say? Basically, when they ask these kind of questions, right, you actually have to describe what Hooke's law is. First and foremost, in order to describe Hooke's law, you always remember how the graph looks like. It's supposed to be a force versus extension graph that is directly proportional first. Then after that, reach the elastic limit, and then it starts to bend downwards, right? From here, based on the graph, you can explain Hooke's law. Hooke's law states that the force is directly proportional to the extension, provided that the elastic limit is not exceeded. Hooke's law states that the force on the spring is directly proportional to its extension, provided that the elastic limit is not exceeded. Okay. Then moving on, each athlete pulls the handle towards himself with a force of 1,300 newtons. State the tension in each spring here. So if each of them is pulling them by 1,300 newtons, right, it means to say each spring, there's 5 springs here, right? So if I want to find out the tension for each spring is basically 1,300 divided by 5. 1,300 divided by 5, I would get an answer of 260 newtons. 260 newtons here. The chest expander stretches and each spring is now 0.94 meters long. This is not the extension, guys. Original length was 0.63. So in order to find the extension would be 0.94 minus 0.63 here, which is essentially 0.31 meters, right? Yeah, 0.31 meters here. Then they ask us to find the spring constant. Yet again, F is equals to Kx. So K would have been equals to F over X, right? In this case here, it will be 260 divided by 0.31. From here, 260 divided by 0.31. Press that in the calculator and you'll get a spring constant of 839 Newton per meter here. 839 Newtons per meter. And finally, oh no, not finally, state the energy changes taking place as the two athletes use their muscles to stretch the chest expander. These muscles here gain energy from the chemical energy from the food. So it's essentially going to be chemical energy into elastic energy, which is obviously everything related to springs lah. Okay. And then finally, state 2 conditions which must be true for an object to be in equilibrium. I mentioned this before. In IGCSEs, they love to ask this question. And the 2 conditions for it to be in equilibrium is always to be 0 resultant forces and 0 resultant moments. Okay. Then figure 2.1 shows a uniform meter ruler P and Q in equilibrium. In equilibrium with pivot is basically going to test you on moments in equilibrium. The distance PQ is 100 cm. The mass of the meter ruler is 0.12 kg. The mass of the meter ruler is 0.12 kg, meaning to say at the middle here is 0.12 kg. Change that into newtons, will be 1.2 newtons. And the weight is W, which is 1.2. On figure 2.1, draw and label an arrow to show the force W acting on PQ at the center of mass. Obviously, the center of mass is going to be here. This will be your W. An arrow to show the force R acting on PQ at the pivot. This is basically going to be your reaction force, which is going to be acting on the pivot here, right? By taking, oh God, there's one more. By taking moments about the pivot, calculate F here. I need to find how much is this F here. Now, first and foremost, I must identify that this is obviously in equilibrium. And in order for it to be in equilibrium, it's basically going to be moments in equilibrium in this condition here. Moments in equilibrium states that it is the anti-clockwise moment is equals to the total clockwise moment here. From here, how many anti-clockwise moments are there? there's one here, and then there is another one here. So it's basically going to be F1d1 plus F2d2 is equals to my clockwise moment, which is this one here, right? Is going to be equals to my F3d3. From here, once I've identified all this information, all I need to do is substitute in 0.5 multiplied by 10 plus with my F multiplied by 90, because this is a 1 meter ruler, right? So 0.5 multiplied by 10 plus with my F, I don't know how much that is, multiplied by my 90, right? Because this is 90 here. Then is equals to my F3, which is essentially 1.2 multiplied by the distance to the pivot, which is going to be 40 here. Today, if I do algebra, 1.2 times 40 minus 0.5 times 10 divided by 90, I'll get the total force of 0.48 newtons. I'll get 0.48 newtons here. 0.48 newtons here. This F here will be 0.48 newtons. Okay, and finally they ask us to calculate the reaction force R here. From here, I just need to understand that the total upward forces are equals to the total downward forces. And right now, how many upward forces are there? Let me rub everything away first. Right now there is one force here, there's another force here, there's one force here, and there's another force here. Here, the downward forces is 0.5 and 1.2 newtons. Here, the upward force is 0.48 and this R here. From here is basically 0.5 plus 1.2 is equals to R plus 0.48. 0.5 plus 1.2 is equals to R plus 0.48. Press that into the calculator. 0.5 plus 1.2 minus 0.48. You get a final answer of 1.22 newtons. 1.22 newtons here. Okay? And finally, the last question here. State in words the equation that defines moments of a force. You're basically supposed to understand that moments is force times distance, right? So, yet again, moment is the turning effect due to the force that acts perpendicularly against the distance of the pivot. Moment is the turning effect due to the force that acts perpendicularly against the distance of the pivot. State what is meant by a moment. Oh, this should be at the bottom here. And this is just the product. Force times distance, sorry. Moments equals to force multiply by the perpendicular distance to the equation. And after that, force is a vector quantity. Explain what is meant by the term vectors. Vectors have magnitude and also direction. And finally, figure 2.1 shows a tower crane used to lift a load on a construction site. Explain how the counterweight prevents the crane from toppling over. This counterweight is basically producing an anti-clockwise moment which balances this clockwise moment here, right? The counterweight produces an anti-clockwise moment that counters the clockwise moment due to the load. Okay, and this is basically how you're supposed to answer all these questions here.